Good afternoon. This is Akanksha Shukla from Information Technology Department. Today I am going to discuss some more things, or I am going to discuss about the topic fuzzy logic, which I had discussed already in my previous lecture. But today I will continue the same topic. So I am going to revise or review about the fuzzy logic, that what is basically the fuzzy logic is. Basically the fuzzy words means that the things which are not clear or the things which are uncertain. So sometimes what happens, we are not be able to decide in the real life problem that what are the solution for that particular problem apart from the true or false solution that can be provided by using the Boolean algebra. Okay, so at this time what we do, we had to select a concept, or we have to select a strategy which can provide the solution between these two terms, either true or false. Just I want to give the example. Just somehow I have to identify that whether just like in the given example, that we have to identify that whether the water is hot or not. So by using Boolean logic, we have only two solutions, yes or no. But when we use fuzzy logic, then they have many, or we can say that there are multiple solutions by using fuzzy logic to identify the problem or to solve the problem, that is the water is hot. So we can have multiple solutions, just like we can give the values or we can give the solution for a particular problem in more precise manner by using the fuzzy logic. That is it hot water, then we can have three solutions, very much, little or very less. So apart from 0 or 1, apart from yes or no solutions, there are many more solutions for a particular problem which cannot be decided by using the Boolean logic in the real life problems. So for these problems, we have a fuzzy logic solution to provide the solution for that particular problem statement. These things I had already discussed, that the concept was introduced by Lohi Zadeh in 1965, and the Boolean system has only two possibilities, 0 or 1 or true or false. But within the fuzzy system, there are multiple possibilities. Okay. So these things I had already discussed, and the characteristics of the fuzzy logics are: the concept is flexible and it is used for helping the minimization of the logics which are created by the human beings, best methods for finding the solution for those problems which are uncertain. Basically, the fuzzy logic or fuzzy system is used to identify the solution for that problems which are uncertain in our real life examples. Okay. Apart from these characteristics, one more characteristic is that it always offers two values which denote the two possible solutions for a particular problem statement. Okay. Also, it allows the users to create the functions which are non-linear of arbitrary complexity. Means not only the use of fuzzy logic can also be used, or we can also use the fuzzy logic system to give the solutions or to build the functions for the problems which are non-real. Basically, in the current time, the most of the problems of our real world are non-linear. So that's why the advantage of fuzzy logic becomes more enhanced. In the fuzzy logic, everything is a matter of degree. Okay, means here what we have to do, if we have to identify the degree of anything or the degree of a particular problem, then you can also solve this degree by using the fuzzy logic. Just like example, let us take an example, that if the speed of a car is between 0 to 40 to 80, okay, so you have to identify that whether the speed of a car is fast or slow. So from 0 to 40 it is slow, but above 40 it is fast. But if you have to identify the degree of fastness or slowness of the speed of a car, then for finding that degree of fastness or slowness of a car, you have to use the fuzzy logic, or with the use of fuzzy logic you can easily find out the solution for that particular problem. Okay. It is also based on natural language processing, and also fuzzy logic can be used by the quantitative analysis to enhance the algorithm execution or to enhance the speed of the algorithms. Now, what is the architecture of a fuzzy logic system? Basically, what we say in the architecture of fuzzy logic system, each component of a fuzzy logic system plays a very primary or important role. Basically, the four components are there in the fuzzy logic. First one is rule base, second one is fuzzification, third one is inference engine, and the third one is defuzzification. So these 4 components together forms the fuzzy logic system. Here we can see the diagram. First of all, what we do, we put the input to the fuzzification module. After that, the rules which are implemented or which are specified can be put or can be inserted through this module. After that, the fuzzy input and the rules are together as an input fed to the inference engine, and we get the fuzzy output. That fuzzy output will again move forwarded to the defuzzification module, and we get the output here. Okay, so from crisp input we get the crisp output using inference engine only. Here 2 modules are placed here, fuzzification module and defuzzification module. From fuzzification module you get the fuzzy input, then it again put as an input to the inference engine, from which or into which the rules or the specified rules are also inserted to that particular module. From that inference engine, from the fuzzy input and from the on the basis of the rules, we get the fuzzy output, which again sent to the defuzzification module, and we get the desired output here. Now, what do you mean by the rule base? The rule base component basically implies or basically used to store the set of rules. Basically, these rules are in the form of if-then conditions which are provided by the experts, and these rules are used for controlling the decision making systems. Means the rules which are given here, or the rule base module consists of the rules in the form of if-then conditions which are provided by the experts, and these rules are only used for controlling the decision making system of that particular fuzzy logic system. Means if there are so many updates that comes in the fuzzy theory recently we have seen that most of the updates are coming, but the most effective methods for designing and tuning of fuzzy controller is that one is the rule base. Okay, so these updates or development decreases the number of fuzzy sets of rules. Means as time goes on, the updates or the developments in the regarding the designing and tuning of the fuzzy controllers are developing more and more. So though these developments are increasing, so on the basis of these developments, the updates or developments decreases the number of fuzzy sets of rules. Means as more as the development regarding the designing and tuning of the fuzzy controllers improves or enhanced, then the number of fuzzy set of rules will be decreased only. Next one is fuzzification. Basically, this is a module or a component which transforms the system inputs. Means this module, fuzzification, converts the crisp number into the fuzzy steps. Okay, whatever the input we are getting at the initial level, that particular fuzzification module converts that crisp numbers into the fuzzy steps. Okay, so these crisp numbers are nothing, just the inputs which are measured by the sensors, and after that the fuzzification pass them that control systems into that control systems for further processing. So this component basically this component basically divides the input signals into the following 5 states in any fuzzy logic architecture or in any fuzzy logic system. So what are the 5 states? First one is large positive LP, second one is medium positive MP, third one is small, then medium negative, then large negative. So fuzzification basically divides the input signals, whatever the input or whatever the crisp numbers are provided as an input to the fuzzification module, then this module converts that crisp numbers into the fuzzy steps. Okay, after that the fuzzy steps are further divided into the 5 states. 5 states are large positive, medium positive, small, medium negative and large negative. Next one is inference engine. The third component is inference engine, which is the main component because all the information is passed in the inference engine, as I had already seen in that particular diagram. That fuzzy input rules, all the information on behalf of input will be passed to that particular module. So this module plays a very important role, or this is the primary component of the fuzzy logic system here. because all the information is processed in that particular inference engine. So what inference engine do? It allows the users to find the matching degree between the current fuzzy input and whatever the rules are passed to that particular inference engine. So inference engine matches the degree between the current fuzzy inputs and the rules. Suppose just in the previous example, I had said that we have to identify the degree of fastness or degree of slowness of a speed of a car. So you have provided particular some rules or some specified rules. So on the basis of that rules, you have to find, suppose I had declared or I had specified the rules that above 40, greater than 40 will be considered as fast, okay, and slow, and lesser than 40 will be considered as a slow. So these rules I had specified earlier. So whenever the input data will be passed, suppose we pass the input data 42. So whenever the input data will be passed to that particular inference engine, then that inference engine match the degree between that particular fuzzy input 42 and whatever the rules you have specified into that particular rule based engine, and after that rules are transformed to the inference engine. So that matching of degree between the fuzzy inputs, current fuzzy input and the rules will be performed by the inference engine only. Okay. After the matching degree, then this system, what this system does, this system determines which rule is to be added according to the given input field. Means when the matching performed, after the matching degree, this system determines what? This system determines that which rule is to be added as per the input is passed to the inference engine. When all the rules are fired, then they are combined for developing the control actions. Means whenever all the rules are performed or all the rules are fired or activated, then all these rules combined to develop the control actions or to develop these controls. So on the basis of that controls, the fuzzy output will be generated from that particular inference engine. Third one is de-fuzzification. This is also a modular component which takes the fuzzy steps or fuzzy set inputs which are generated by the inference engine. Then what this de-fuzzification do? This module takes the fuzzy set inputs which are generated by the inference engine and then it transforms them into the crisp value. Means at the initial level, what was the input? The input was the crisp value. So in the de-fuzzification, what we generate the crisp value input, or we convert the crisp value input into a crisp value output. It is the last step in the process of the fuzzy logic system. The crisp value is a type of value which is acceptable by the users, and for this various techniques are performed, but the user has to select the best one for reducing the error here. Okay. So various techniques are available, but what the user has to do? It has to select the best one for reducing the error only. So these are 4 components for the architecture of fuzzy logic. First one is fuzzification, rule based, inference engine, and the last one is de-fuzzification. Now these are the different application areas where the fuzzy logic concept is widely used. The first one is it is used in the business for decision making support system. Whenever in the business or in the organizations we have to perform the business areas, then if you have to take the decisions or you have to perform the decisions right now, then what you have to do? The decision is a part where you can't declare the solution for that particular problem into true or false value. You have to, if you are taking any decision, then you have to tell that what is the accuracy of that particular decision. Okay. So somehow in form of degree you have to declare you have to decide the decisions as per problems. So basically the fuzzy logics can be applied in the businesses for the decision making support systems. Second one is it is also used in automotive systems. Basically the fuzzy logics are used in automotive systems for controlling the traffic and speed and improve the efficiency of automatic transmissions. Means automotive systems also use the shift scheduling methods for that particular automatic transmissions. So whenever you have to perform the automatic transmissions to control the traffic and to control the speed of a particular vehicle or particular system, particular machine, then you can use the fuzzy logic concept here. The next one is it is also used in the defense in the various areas. Defense mainly uses the fuzzy logic system because whenever we are considering the underwater target recognition. Then at that time, what the defense used? The defense used the concept of fuzzy logic, because the automated target recognition of thermal infrared images are a very concerning area under the defense. So, for this purpose, the defense used the fuzzy logic system. Okay. Fuzzy logic systems also used in securities, or for security purpose, fuzzy logic systems are also used. It is also used in the pattern recognition and classifications in the form of fuzzy logic based recognition. Also in the handwriting recognition it is used. For searching the fuzzy images, fuzzy logic system is also used. So these are the various application areas where the fuzzy logic concept is widely used in current time. Next one is microwave. It is also used in microwave oven for setting the tunes, power and cooking strategies. Okay. So fuzzy logic system is also used in our daily life or real world examples, just like in the microwave oven. Okay. So this technique also used in the area of the modern control systems, where we have to control the systems in various forms, just like in the expert systems. Finance is also another application area where this concept is used for predicting the stock market and for managing the funds. On the basis of that result, or on the basis of that prediction, what we do, we can manage the funds. Okay. So that's why fuzzy logic system is also used in finance. It is also used for controlling the brakes, and also in the industries of chemicals for controlling the pH and chemical distillation processes. Also in industries of manufacturing for the optimization of milk and cheese production. Also in the vacuum cleaners and the timings of the washing machines. So we can see that many of the applications which I had discussed in this particular slide, we have seen that most of the examples we can see in our daily use life. Okay. It is also used in heaters, ACs, air conditioners and humidifiers. So most of the real world examples we can see here which uses the fuzzy logic concept. Now, what are the advantages of fuzzy logic? It has various advantages or pros. The first one is this methodology is similar as the human reasoning. Okay. Next one is any user can easily understand the structure of the fuzzy logic, because it is a very simple architecture. It is having a very simple architecture. So anyone can easily understandable. The structure of fuzzy logic is easily understandable for any user. It does not need a large memory. So the algorithms can be easily described with the fewer data. No complex or no large algorithms are present in the fuzzy logic system. So it is easily memorable and it is easily identified with the fewer data. No description of the algorithms, or it doesn't need a large memory also. It is also wide in all the fields of the life. Just I had given examples previously, and it easily provides the effective solutions for the problems which have high complexity or which are having the high uncertainty. So this concept is also based on this fuzzy set theory. Basically, the base of the fuzzy logic system is the fuzzy set theory of mathematics. So that's why it is a simple methodology. Now we will discuss some disadvantages of the fuzzy logic. So it is also, apart from advantages, it is also having some disadvantages or limitations. Some of them are the runtime of fuzzy logic system is slow and it takes a long time to produce output. So for producing the output or for producing the solution of particular, apart from that, it provides a multiple solutions, but the runtime of fuzzy logic system is slow because it takes a long time in producing the outputs. User can understand it easily if they are simple, but if the problem is complex or if the problem is containing a very uncertain data, then using the fuzzy logic also user can have some problems. Okay. The possibilities which are produced by the fuzzy logic systems are not always accurate. Somewhat it is accurate, but sometimes whenever the data or whenever the problems are complex and whenever the degree of uncertainty in a particular problem is high, then the possibilities for the less accuracy for that particular solution is more. Many researchers give various ways for solving a given statement using the techniques which leads to ambiguity. So it has been proved or it has been specified or identified by the many researchers that using the fuzzy logic, it gives the multiple solutions, but the statement solved for a given statement using this technique can lead to ambiguity. Means the output can produce the output of the data which are produced after the inference engine produces the data, then that data may contain the ambiguous data. Means the things are not clear, or the things are somehow ambiguous. Means the things are not clear. The solution for a given particular problem somehow or in some cases it may lead to ambiguity also. Next one is fuzzy logics are not suitable for those problems which require the high accuracy. As I had said also that the possibilities produced by the fuzzy logic systems are not always accurate. So if a particular problem needs the more accuracy or needs the high accuracy for that particular problem, then this particular system or this particular logics may not be suitable for those problems. The systems of a fuzzy logic systems also need a lot of testing process to verify and to validate the particular data. So the system of a fuzzy logic system, it needs a lot of testing process to verify or to validate the data. Now we will discuss about the fuzzy decision tree. It is based on the reduction of the classification ambiguity with the fuzzy evidences also. Here also just like a decision tree in which what we do on the basis of the rules or on the basis of the data which are provided, we build a decision tree. Okay. So here also the tree will be maintained, but the data, the initial data which are given here is the fuzzy evidences. So this tree also contains many branches and leaves, and each leaf represent a category which is similar to a specific object only. The root node represent that category which has no subcategories. Okay. So fuzzy decision trees are more efficient for treating the learning data of mixed type, including both numerical and categorical data. Basically, the data can be classified, or the data can be of two types, means qualitative data and quantitative data. Qualitative data contains the data which is in the textual form, and the quantitative data contains the numerical data. So for quantitative data, we have to perform some calculations, or we have to perform the numericals on that particular data. So these fuzzy decision trees are more efficient for treating learning data of mixed type. Means if you are having a data containing both qualitative or quantitative and and also the categorical data, then that fuzzy decision trees are the best solution for that particular mixed type data. They are also most robust in tolerating the imprecise, the conflictions and the missing information. Means just like noise, if the particular data contains any noise, then for handling these types of problems, the fuzzy decision tree can be the best solution. That's all for today. Thank you.